Hi there, I'm Leo from Firecrawl, and in this video, we'll be taking a look at the new models for our agent endpoint. If you have not selected any models and you're using agent, you're probably going for the Spark 1 Mini, which is 60% cheaper. If you want a better accuracy for complex search, critical extraction, then you should probably aim at using the Spark 1 Pro. Now, before moving forward with these models, let's understand why to use the agent endpoint at all. So here I have an example inside of the playground for Firecrawl where I asked it to search for Firecrawl's search endpoint and get back a short description along with a usage example. What it did with an emphasis on being a single endpoint to do all this is generate the exact response in a structured output that I can now use for my workflows, for my code, like building apps such as this one. The playground example was pretty simple, but creating something as complex as going inside of a documentation, grabbing everything specifically in the way that I need it to be generated is something else. And before the agent endpoint, we would have to configure all this manually ourselves. While now it's as easy as sending over a prompt as well as a schema. My agent prompt is right here. It basically describes the guidelines from Claude to produce a Claude skill. And then all the way down here, we have the schema. This schema helps the agent from Firecrawl understand a bit more of each of the different fields that it needs to fill in. Then down here comes our single post request over to Firecrawl's agent endpoint to have it work on our task. If we were to implement this manually ourselves, what we would have to do is get the URL that the user sent. Let's take this over to Excalidraw since it's much easier to explain. We'd have to access that URL, then either crawl or map everything. I suppose maybe mapping, because then we'd give the mapping context to the LM without exactly crawling through things that we might not need inside of the context. Now, once we have mapped everything, we would now probably have an array full of URLs. So URL2, URL3, and so on. We would send these URLs over to an AI agent. After the AI agent reads these URLs, it would then process and understand, okay, so this URL is about an endpoint, this URL is about SDKs, this is for integrations. So if it doesn't really care about neither one of those, it's going to keep searching until it finds all of the endpoints that it should be finding. So since neither one of those might be related to the search endpoint that I asked for, it will keep searching until it actually finds the endpoint required right here. Now that it has the URL, what it will have to do is go inside of that URL, scrape everything that is in here, bring it back to the context window, rationalize into what is the structured output that it should be structuring the data, structure the data, and then output all that. And all this would have to be created by us. If this wasn't that clear, let me explain using NAN, which has a visual interface, should be fine for no coders as well as coders. So once you have a chat message trigger, you send that message over to an AI agent. After you send it to the AI agent, you have to empower that agent to have access to different tools that can manage all this. Firecrawl also provides these tools. So if you're building something that you already know the direction that the agent should go through, you can specify and niche down that agent to do exactly what you need it to do. You can optimize the cost much more with your own agent. But if you need it to be dynamic and handle more use cases, just go for the agent. Now, if I were to build the entire agent, I'd select the Firecrawl tool, select scraping, make the URL input field dynamic so that the AI could assign that value. Now we need to add another tool. So we only have scraping. We need it to also map and search. Okay, so we've also added that, made the URL dynamic. Okay, now it has that one more tool. Now we have to add another tool, which could be the crawling tool. Pretty nice. Let's make that input field dynamic as well. And there's much more tools that we could add. But just as an example, now we also need the AI agent to output in a specific format. So now that I've toggled that, let's add the structured output parser. Here is where we define the schema that it might output for us. So if you want to get the code in JavaScript, here's the schema. It uses Zod. But if you don't want to use Zod, you just want to go with a specific schema like this. Let's go all the way down here, all the way to required. Let's go back to NAN and just place that in there as an example of what you would have to do to actually configure a statical output. This wouldn't be dynamic. And to actually make it produce dynamic outputs based on the data that it's given, you would have to add quite a lot of system prompting in here. And once you did all this, it'll have basically 5% of the potential that the actual agent endpoint really has. I mean, just by looking at the playground's activity, you see how much tools that it's using. Like using sub-agents create, initializing browser. Once it initialized the browser, it actually did a bunch of different operations just to find exactly what we need. And just to give you a sneak peek of what was generated by just using the agent endpoint to generate Claude Skills, this is it. Look at the size of these files. And look at the precision. The skill markdown file has a specific structure that places a name and description, and it follows along with this perfectly. Creates a decision tree when to use. Then at the very end, it provides where each one of these different files are. And to make sure that you're using the more accurate model, all you have to do is add this to the body request for agent. So model and then Spark 1 Pro. Or if you specifically want to mention Mini, you can just add that as well. And that is it for this video. If you want to take a look at how Agent was implemented for this project, take a look down in the description of the video for the link to its GitHub repository. Thanks for watching, and we'll see you in the next video. Till then.